In this video, I will show you how to create a virtual test for DIC with EikoTwin Virtual and the add-on of Blender, BlendDIC. The first step is to open Model Converter. With it, we can import a model file from Abacus, Paraview, SamSef, Hyperview, and convert the mesh into a VTK file that can be imported in Blender. And we also import the simulation results to import each step of the simulation to create images on Blender. Now we can import this mesh in Blender. It looks like this. It's a wing of plane, and we can apply a texture on it. Load and apply texture. This texture is a speckle pattern made from many dots, and we can modify the size of it with this button. After that, we can import the environment mesh, which looks like this, and add some cameras. We can add cameras from a preset we have, or create new cameras with specific focal length, sensor width, height, and resolutions. Here I have created two cameras, and I can modify their position and have a direct render of their view in this interface, like this. So we can make sure that we can see what we want to look at and be aware of the environment as well. We also have many information for the cameras, like the location of them, and we can also compute the stereo angle, which is really useful for the IC. It's the angle between the mesh and both of the cameras. We can also show the sharp area. It's the space where we have image very sharp, and outside of this volume the image will be blurry. We can add also some lights to have a realistic render. We can modify the power of the lights, the spot size, and what is the target. We can import a calibration board to make sure that we can calibrate cameras and choose which board we want to use. We can add some markers on the mesh. Like this, and add some pre-calibration points for the calibration. And then with this button we can preview the displacement of the mesh during the test. Is the mesh displacement imported from the simulation. And finally, when we are ready to render, so we have well placed the cameras, the lights, and the mesh, we can render images for cameras and add, for example, some noise to have realistic render of images and some intermediate images. Export also parameters from the calibration, like the projection matrix and calibration points. To communicate with the team about the test, we can create a video of this test. So create communication cameras and have a view of this test with a nice video.